Hello everyone, good morning. Am I audible? Yeah, perfect. Okay, so let's begin with the session, guys. So today it's just the continuation of where we stopped in the last session. So that is nothing but collections here. Okay, so again, as we spoke in yesterday's session, previous session here, collection is a very important topic that you're supposed to be aware of, right? So let us try to talk about a few things under collection here. Okay. So in the previous session, the first topic which we discussed was something called as data structure, right? What is a data structure? Data structure is a way of storing or organizing the data here. So we have a large amount of data here. Okay, we have millions of data here. Okay, so we have to store them or organize them in one particular order. So that is nothing but we are following a data structure here. It's a way of storing or organizing the data here, right? And then slowly we understood what is a variable, what is an array, and what is a collection as well. So we understood the difference between array, variable, and collection. In simple terms, variable, array, and collection are all containers in order to store some data here, in order to store some objects. Variables also used to store, array is also used to store, and even collection is used for storing purpose only. But the most important point here is, okay, variables are used to store a single object. Okay, variables means it will always store a single object, whereas array and collections will store a group of objects here. Variable will store a single element object, but array and collections will store a group of objects, a group of elements here. Okay. What is the necessity of collection then? The necessity of collection was array had certain drawbacks. To overcome those drawbacks only, we have collection here. Okay. So the first difference was who stores only homogeneous type of data? Array stores only homogeneous type of data, whereas collection will store both homogeneous and heterogeneous type of data here. Okay. And the next point, array is fixed size. Okay. So it's always fixed. Okay. It does not increase or decrease its size. But collection is dynamic in size. It can increase or decrease its size based on the requirement here. Okay. Who does not have methods at all? Array does not have any methods at all to work with the data. But collection has a lot of predefined methods. Okay. Like add method, remove method. We have so many important methods under collection here. And there is a topic called as generics. Okay. That generics array will not support. Array will never ever support the topic called as generics, but collection will support the topic called as generics here. So in simple terms here, what is a collection? A collection is a predefined interface in java.util package. And when was it started from? JDK 1.2. And what is the use of it? Storing a group of objects. Okay. Collection is an interface in java.util package, and it was introduced from JDK 1.2, and the use of collection is to store a group of objects. Okay. And the reason why am I repeating all the things, revising all of those, is because I want you all to be strong in this particular concept. That's the reason I'm taking little bit of extra effort in making sure that you all understand the topic here. Okay. And then we also saw the correction hierarchy, right? Collection is the supermost interface. Under that, we had three sub interfaces. Okay. I told you to remember what is it? Set, queue, list. Correct? We go in this order, right? List, queue, set. Right? Under list, four classes we had. Okay. That is array list, linked list, vector, stack. Array list, linked list, vector, stack. So these are the four implementation classes under list here. Under queue, two classes. Linked list, priority queue. Linked list, priority queue. Under set, three more classes. Hash set, linked hash set, and then one more thing which is very important later is something called as tree set here. So these are the important implementation classes and interfaces available over here. And collection in turn will inherit one more interface called as IEEE. Okay. iterable or iterable is one more interface which the collection will inherit. Okay, but the supermost interface in collection hierarchy is collection only. But that will again inherit the interface called as iterable here. Okay, so this is what we are supposed to understand over here. Clear? So these are the few things which we saw here. Okay, and we saw so many methods also, right? Under collection, okay, we saw a few methods. Under list, we saw a few methods, correct? And now we also saw the implementation of array list as well. When I create an object of array list, what will happen? Internally, an array will get created of size 10. So when I create an object of array list, internally an array will get created. Okay, and the size of that array is 10. Okay, that is initial capacity is 10. I keep on adding the objects one by one, one by one, one by one, one by one. So once the array is full, but still if I try to insert an object here, what will happen? A new array will get created based on the incremental capacity formula. Correct? Once the array list is full, once the collection is full, but still if you try to add an object here, a new array will get created. And the size of that array is depending on the incremental capacity. That is current capacity into 3 by 2 plus 1 here. Clear? So these are the few things which we are supposed to understand. Okay. And then all the objects from the old array will get copied to the new array, and the reference which was pointing to the old array starts pointing to the newly created array. Okay, and we also saw so many the underlying data structure is resizable array or growable array, and it is also implementing few interfaces with respect to list as well. Okay, so these are the specifications. We also saw certain specifications. No, insertion order is maintained, duplicates allowed, it is indexed based, and even null values can be inserted. Okay, so make sure guys, never ever afford to miss out on a single topic as well. Each and every topic has to be in your mind. Okay, so these are the few things which we are supposed to be aware of when we talk about collection here. Okay, so go through everything. Okay, I have uploaded one notes, okay, handwritten notes of one of my students here. Okay, refer that notes here. Okay, you will have entire collection notes here. Okay, refer it in detail. I have done it over there. Okay, download it, keep it for your reference, or if you want to prepare your own notes here, do it for you. Okay, but make sure you try to understand the topic in a beautiful manner. Okay, so this is all about the basic things which we have covered in the previous session. In today's session, let us try to talk about something called as linked list here, the second implementation class of the list interface. Okay, linked list is also an, what is linked list? It's a predefined class in java.util package. Okay, linked list also, it's a predefined class. Okay, it's an implementation class of the list interface. Okay, so it was present in java.util package, and it was introduced from JDK 1.2. Okay, again, collection was also 1.2, list also 1.2, array list also 1.2, and even linked list also was introduced from the second version of Java, that is JDK 1.2. So, whenever we make use of linked list, the objects or the data or information is stored in terms of nodes here. Okay, always, whenever I make use of linked list here, the objects will get stored in the form of nodes here. Okay, and each node, will store the address of, each node will store the address of previous and the next node here, previous and next node here. So this is what we are supposed to understand. This node, it will definitely store the object here. It will definitely store the object plus the addresses of the previous and the next node here. So that's the reason here. Okay, the underlined data structure, the underlined data structure of linked list is doubly linked list here. Okay, doubly linked list here. So you should never ever forget this particular point here. Okay, the underlying data structure of array list is resizable array or growable array, but the underlying data structure of linked list is doubly linked list here. So what will happen, when I try to work around with linked list? I'll show it to you. I will create an object of linked list. Linked list L equals to new linked list of. Okay. I will create an object of linked list. Okay. And I will add three objects. L dot add of 10, L dot add of 20, and I'll tell L dot add of 30. So in the linked list, I am adding three objects, that is 10, 20, 30 here. So always the data is organized. Okay, always the objects are organized in the form of nodes here. Okay, so nodes are nothing but containers. So how many nodes will get created? Three nodes will get created. This is first node, this is second node, and this is third node here. Okay, and each node, okay, will be consisting of three partitions. Okay, each node will be consisting of how many partitions? Three partitions here. Let me write down this, three partitions. Okay, and each node will have certain address. The address of this is 0x1, 0x2, 0x3. Okay, and the first object will get stored into the first node, second node, third node. Clear? So always the data inside a linked list is stored in terms of nodes. Nodes is a container which stores the object as well as the address of the previous node and the next node here. So this is the first node here. Does it have any previous node here? No, it does not have the any previous node. So it is going to store null here. Is 0x1 having next node? Yes. What is the address of that node? 0x2. So then 0x2 is the second node. Does it have any previous node? Yes. What is the address of it? 0x1. And does 0x2 have next node? Yes. What is the address of it? 0x3. And does it have 0x3? Does it have previous node? Yes. The address is 0x2. And 0x3, does it have next node? No. It is going to store null here. So in simple terms here, the objects, okay, the objects inside linked list are stored in terms of nodes, wherein each node consists of the object as well as the addresses of the previous node and the next node here. See, 0x1, 0x2, 0x3. These are the three nodes here, and it is storing 10, 20, 30 respectively. And each node will store the address of previous node, next node, previous node, next node, previous node, next node. If the next node or previous node is not available, it is null here. So in simple terms here, array list is a way of storing the data in one particular order. Linked list is a way of storing the data in one particular order. Okay, so this is what we are supposed to understand. And you might ask one question, sir, what about the initial capacity and incremental capacity, sir? Linked list does not have something called as initial capacity and incremental capacity. Okay, but array list has initial, incremental, both the things are available here. Okay, so in simple terms, I go back to my Eclipse and let me try to, show a few things about it. Okay, this is my Eclipse wherein my wherein I can execute Java programs over here. So collection is my framework. Okay, under collection we have src. Okay, src is the root folder, and I have created a package called as day1. Today will be our day2. Control N, I create a package, and the package name is, I will just write it as day2. So I will create a package by the name called as day2 over here. Okay, so I have created a project and a package by the name called as day2 here. Okay, the next thing, what am I supposed to do here? Okay, let me create a class. Control N, I will create a class, and the class name is demo here. Okay, so project got created, package got created, even a class also got created successfully. Yeah, perfect. Okay, so we have a project, package, and a class, and my execution will always start from something called as main method. Main method is somewhere wherein my execution will always begin from. Okay, now, so I also have my main method in a beautiful manner here. Okay, so the next topic which we are supposed to understand. Okay, I will create an object of linked list. Okay, linked list L equals to new linked list, or I create an object of linked list. Linked list is a predefined implementation class of the list interface. Correct. Linked list is an implementation class of the list interface, and it is predefined and present in java.util package. If any class is present in java.util package, and if I'm creating an object or utilizing it, I have to import it. Common sense, no? I told you most of the collection interfaces and classes are present in util package, so mandatorily I have to import it. Clear? After that, when was it introduced from? JDK 1.2. How is the objects organized in linked list? In the form of nodes. Nodes meaning it will store the object plus the address of previous node and the next node. That is the reason we call it as doubly linked list. It is storing the address of previous and next node also. Okay. And then I keep on adding the objects. See, L dot add of, add method. We know what is the job of add method, don't we? Add method is used to add an object into the collection here. Okay. So a linked list also is a collection only. Okay. Linked list is also a type of collection. I add three objects into my linked list here. I'll maximize the screen. Control M. So now when I try to print the object reference, see I'm printing the object reference, but since toString method is overridden internally, we will not get the fully qualified class name. We don't get the string representation. Rather, we will get the content, whatever we have added here. Okay, because toString is overridden internally. Okay. So now once I see here 10, 20, 30, I get the output as 10, 20, 30 here. Clear? So this is what we are supposed to understand. But now, if I want to look at the implementation class, what will I do? The source code of linked list. See, press Control, hover on that particular class, and click on it. So if you just look at this particular process here, look at the data here, what is happening here. Okay, linked list, okay, implements list here. Plus, it is implementing DQ, clonable, and serializable. So it is implementing all the four interfaces here. See, I told you, right? It is going to store in the terms of node, right? Always the objects are stored in terms of node here. Okay, its size is 0 initially. It keeps on incrementing its size here. Okay, so this is what we are supposed to understand here. Okay, so this is, see, if you want to look at the array list class here, see, this is array list. It will implement list plus random access, clonable, and serializable. Okay, so these are the most important. See, default capacity here is 10, but here, we don't have any capacities here. So that way I have told you this entire data here. Okay, so when I go back over here, linked list also implements what all interfaces? Linked list will implement list interface. With list interface, it will also implement DQ. Okay, it will also implement clonable, and it will also implement serializable. Okay, so linked list, it's only one difference. See, linked list will implement list, DQ, clonable, and serializable. Whenever you talk about array list, it will also implement list, clonable, serializable. But one extra, that one is called as random access. Okay, so this is what we are supposed to understand. Okay, so minute differences, guys, but you're supposed to remember a lot of things over here. Okay, so this is all about the linked list specification. But the only important part is array list will make use of resizable array or growable array internally. It's a way of storing the data. But linked list will make use of nodes, doubly linked list data structure internally. So this is what we are supposed to understand. But now I want to traverse it in using for loop here. Okay, I want to traverse each and every object one by one with the help of for loop here. How can I do it over here? So internally, I will just give you the basic data here. Okay, and linked list will get created. Okay, imagine I just create a linked list over here. I created a linked list, and that linked list is storing three objects. Correct? That linked list is storing how many objects? Just a moment. Oh, where is the size here? Somewhere I decrease the size here. Oh my god. Wait. I'll open a new paint itself. Yeah, great. Okay, so let me do it over here. Internally, okay, so three objects will get stored here: 10, 20, 30. Okay, now clear everyone over here. And the index position, because linked list, array list are all index based. So they are all having index position. If I want to traverse it in for loop here, can I traverse it? 100% no. I can make use of a for loop wherein I can traverse the objects successfully here. Since if I want to fetch 10 here, always the index position starts from 0. So I will tell int I equals to 0. Why? Because I want to fetch 10. If I want to fetch 10, always the index position of the first object is 10 here. I mean index position is 0 here, sorry. So I have to write it as 0. And then later, okay, and then later over here, what did we understand here? I have to gradually increment. See, 0 to 1, 1 to 2. Gradually, I am incrementing by 1 here. So it is I plus plus here. So now if I want to calculate the length over here, what am I supposed to do? Should I make use of length keyword over here? Should I make use of length of method here? And should I make use of size of here? Should I make use of the first option, second option, or the third option? Can you tell me what will be the answer over here? I should be lesser than L dot. Should I make use of option 1, option 2, option 3? Is it the length keyword, length method, or size method? Can you guys tell me, guys? Option 1, 2, 3 here. Any, what am I supposed to make use of over here? Think and tell me, guys. Okay, so in simple terms over here, we are working around with collections. Sir, length is a keyword which we use it on arrays here. Correct? Which we make use of on arrays here. And length method is used on strings here. Whenever we make use of strings, we make use of length here. And since I'm working around with collection here, I have to always make use of size method. In collection, if I want to calculate the size here, it's always the size method. So I have to make use of size method. That is option number 3 here. Got it? And then I am just supposed to print the data over here. Okay, let me just try to print the content here. SOP, and I cannot make use of indexing. I cannot tell L of I over here. Rather, I have a method. What is that method? Get method. L dot get of I. What is the job of get method? It is used to get the data based on the index position, right? So you're just supposed to be a bit of smartness over here. You have to use your smartness level here so that you can get the data. So what is my I value over here? I value is 0. Okay, and I check the condition. Is 0 lesser than L dot size? 1, 2, 3. Is 0 lesser than 3? Yes. Control comes inside. L dot get of 0. What is get of 0? It is 10 here. 10 will get printed. Again, the control goes back. I plus plus. I will become 1. Okay. And then check the condition. Is 1 lesser than 3? Yes. Control comes inside. L dot get of 1. What is L dot get of 1? It is 20. 20 gets printed. Again, the control goes back to I plus plus. I will become 2. So now I check the condition. Is 2 lesser than 3? Yes. Control comes inside. L dot get of 2. Okay, what is L dot get of 2? 30. 30 will get printed. Control goes back. I plus plus. Now I value will become 3 here. Now check the condition. Is 3 lesser than 3? No, stop it. And I have successfully traversed all the objects here. Clear? So this is what we are supposed to understand for traversing. See, if I had an array, integer array x, okay, equals to, okay, 10 comma 20 comma 30, I will always make use of length keyword here. See, x dot length here. See, this is what for arrays I will make use of length keyword. And if I had a string y equals to Java, okay, if it's a string, I will always make use of y dot length of method. See, but for an array, I will always make use of length keyword to calculate the length. And if it's a string, I will always make use of length method or a length function. And if it is a collection, if it is a collection here, I will always make use of, see, L dot size method. See, linked list object is created. So if I want to calculate the size, it is the size method. Okay. So never ever forget this particular content here. Okay. So this is what I just wanted to explain over here. Okay, so now we'll write our for loop here. For if I want to fetch the first object, I mean the first element here, the index position is always 0. And I have to traverse to the last position size and gradual increment by 1. So sys out, and if I want to find out, L dot get of I over here. Okay, so now when I execute it, I will get the object one by one, one by one, one by one. I got the content here. See, this is all about the entire process here. See, when I try to print the object reference, I'll get 10, 20, 30. Then one by one, if I traverse it, 10, 20, 30. And this is the length of array, Java, and the collection here. So that the 343 and I'm getting the output here. So this is how we are supposed to work around with array list and linked list here. And what if I have to traverse it in reverse order, guys? What if I have to traverse it in reverse order? Can you tell me the logic, guys, if I want to traverse it in reverse order? Same for loop only, okay? But I have to make use of some certain logic here. What will I make use of it? Tell me. What will be the condition, guys, if I want to traverse using reverse order here? I want the output as 30, 20, 10. How will I do it here? Any idea? What will I initialize my I value to? I should initialize my I value to what? What should I initialize? Very good. Okay, see here, sir. If I want to, fetch it in reverse order, it's very, very simple here. Okay, see here, guys. If I want to traverse it in reverse order over here, my index position has to be 2. If I want to fetch 30 for the first time, index position has to be 2. So for int I equals to 2, correct? But if I directly write it as 2 over here, that becomes hard coding. Okay, hard coding meaning that works only for 3 objects. If I give the index position as 2, it will work only for 3 objects. So in order to do it, I'll tell L dot size. L dot size will return 3. 3 minus 1, it will point to 2 only. Clear? And since I'm going in reverse order, 2 is greater than 0, 1 is greater than 0, and 0 is equal to 0. So I value should be greater than or equal to 0, and I'm decrementing 2 to 1, 1 to 0, 1 by 1, 1 by 1. So it is I minus minus. So therefore, L dot get of I here. Simple. See, I value is L dot size is 3 minus 1 is 2. Is 2 greater than or equal to 0? Yes. Control comes L dot get of 2. What is L dot get of 2? 30. Goes back. It becomes 1. Is 1 greater than or equal to 0? L dot get of 1. 20. Goes back. 0. It becomes 0. Is 0 greater than or equal to 0? Yes. L dot get of 0 is 10 here. Goes back. Is minus 1 greater than or equal to 0? No, stop it. 30, 20, 10. I got it in a beautiful manner. So it's just about visualization. See, if I just write it as hard coded as 0, it works only for 3 objects. Okay, I can just write it L dot get of I here. So what if I just give see, now when I execute it here, it works fine. Absolutely. Oh, I'm so sorry. Greater than or equal to 0, and it is I minus minus because I'm going it in reverse order here. So when I execute it here, I get the output here 30, 20, 10 here. Yes, I absolutely got it here. And this will work only when I have 3 objects. What if I have one more object, L dot add of 40 here? So now it will not work because I have hard coded it and told it as only 2. So it's going to start it from only the second index position. If I want to dynamically calculate it over here, I have to tell L dot size minus 1 here. So now it will calculate. Length minus 1 will be the last index position. I get the output here. So that way you are just supposed to understand and get the content here. So what have we done over here? We created an object of linked list. We added 4 objects and we printed it. We are trying to print in forward direction also, reverse direction also. And then length is used for arrays, length function or length method is used for string, and size is used for collection here. Okay. So when I execute it, I get the absolute content over here. Okay. So this is how you are supposed to be, strong enough in this particular order here. Clear? So anyone having any confusions with respect to whatever we did now? Anyone having any confusions, guys? Any questions? You want me to repeat anything? Any questions? Anyone? Perfect. Okay. Duplication is allowed. Okay. There's one question. Duplication. Yes. How? See, list has 4 specification. That is insertion order is maintained, duplicates allowed, index based, null value. So all those four specifications of list interface are followed by all the four implementation classes. Array list, linked list, vector, stack are all the implementation classes of list, correct? So obviously the specifications of list should be followed by them. Okay, so duplicates, null, everything is allowed. Okay, not a problem. Okay, so this is how we are supposed to understand. Okay, so now I'll do a few more methods over here. I'll have a test class and I will have a method. Okay, main method. So here let me create an array list here. Okay, see here I'll create an object of array list. This angular braces ignore. What is it? I'll tell you later. This is only called as generics actually. I'll write al equals to new array list of. Okay, I create an object of array list and I'll tell al dot add of 10 and al dot add of 20. Okay, so now I will try to print the al object here. Okay, and then later I'll create. I'm done with this process. I'll create an object of linked list now. Linked list ll equals to new linked list of. Okay, I have to just create an object of linked list here. Okay, and I have to import linked list also from the predefined package. See, I am importing both the classes here. See here, array list object I've created, I'm importing from java.util. Linked list object I'm creating, I'm importing from java.util. Okay, so I've created an object of array list and I've added two objects 10, 20. And if I try to print those, if I try to print al, what will be the output here? 10 and 20, because it is storing two objects over here. So I'm getting 10 and 20. Plus, I will try to concat the size also. Okay, al dot size here. Okay, I'll just write it as, okay, size here. Okay, so directly I'll just write it as size colon that respective data, and here I'll write it objects inside array list here. That way, I can just concat it. So now when I execute it here, beautiful, I'll get here, see, objects inside array list 10, 20 and the size is 2 here. So that way we will get the content here. If you want to give a little bit extra spaces over here, you can give it here. So now it looks comparatively better here. See, now when I execute it here, what are the objects inside array list? 10, 20 and the size is 2. Correct now? So now here I will make use of linked list here. See, I created an object of linked list. Okay, I'll tell ll dot, I will make use of add all method, add all of al, and then I'll tell ll dot add of 30 here. So now similarly, when I try to print this particular content here, look at the output here, objects inside linked list now. Okay, I'm just writing the objects inside linked list now. What will be the data here? So now once you just closely observe, okay, what will be the output here? You will get to know it. So now when I execute it over here, look at the output. Wait. Yeah, this is about it. I'm just trying to print this ll over here and ll dot size here. So now when I execute it, look at the output. What did you understand here? Array list is storing 10 and 20 and the size is 2. When I tell line number 20, observe in line number 20 here what is happening. ll dot add of al. So what is the job of add all? Add all is a method used to add all the objects from one collection into another collection. Array list is a collection storing 10 and 20. So all those objects are added into the linked list one by one. After adding 10 and 20 from the array list, I am also adding 30. Therefore, the size is 3 here. So what is the job of add all here? So the job of add all is, okay, so I'll just write it as add all method is used to add all the objects of one collection into another collection. Clear everyone here? This is the specification of add all. Add all means it is used to add all the objects of one collection into another collection. In this scenario, I have made use of one array list and one linked list. You can make use of two array list also, two linked list also. That combination will work. Okay, it's ultimately a collection. You can make use of array list 1, array list 2, linked list 1, linked list 2. That way you can try to manipulate here. Got it? Similarly, wait for it. Control N, I create a class called as example class here. Okay, and I will have my main method over here. So I hope you all got the clarity here, right? So now I can also make use of star, guys. Okay, when I make use of star over here, hashtag over here, it means I am importing all the classes and interfaces from java.util package. I can avoid java.util.arraylist, java.util.linklist. That way I can avoid. But when I use hashtag means imports all. Okay. Now in this specific scenario, look here. I create an object of array list and I've added 10, 20. So now objects inside array list are nothing but 10, 20 and the size is 2. Perfect. We're done with this entire process. And I have a linked list object. Okay, I have what? Linked list object. So now here I tell L dot add all of AL and I've added also 30. So what is the objects inside linked list? It's 10, 20, 30. Okay. And then we are just trying to check this data here. Now what I'll do, I will just do one more data. Okay. So, let me try to add one data. So here sys out LL dot contains all of AL. So when I execute this program over here, okay, I will get it as true. Okay, why did I get it as true over here? Why did I get it as true over here? Contains all is a method to check if one collection is having all the objects of another collection. Contains all means it checks. Okay, linked list is checking if it has all the objects of array list or not here. Clear? So I get the output as true over here. Now I will tell ll dot remove of, okay, whatever is present in index position 1. Okay, so now later I will tell sys out ll dot contains all of al here. Okay, after that I will try to print also. Okay, I'll try to print also. Okay, so before removing what was the data here, okay, and after removing what was the data here. Okay, so now when I executed, okay, see initially what was the output? Just check this data here. Wait, just look at this four specifications over here. Okay, just look at this four objects inside linked list. Okay, it is having 10, 20, 30, size is 3. Perfect. Now 10 and 20 are the objects of array list. So is it containing all the objects of array list? Yes, it's true. Now I have remove of 1. Remove of 1 meaning 20 is removed. So therefore objects inside linked list are 10 and 20, 10 and 30. Size is 2. Now if I check if the linked list is containing all the objects of array list, now it gives false here. Why? Because 20 is not available at all. So that's the reason we get an error over, false over here. So what is the job of contains all over here? So the job of contains all is nothing but, okay, it is used to check if all the objects of one collection is it available in another collection or not here. See here, I'll just write the specification. What is the job of contains all method? Contains all is used to check if all the objects of one collection is present inside another collection or not here. Okay, used to check if all the objects of one collection is present inside another collection or not here. This is the specification of contains all here, right? So this is how we are just supposed to understand. And similarly, we have one more method. Okay, I hope you all understood what is add all and contains all. Okay, now we'll try to write a remove all. Okay, see here I'll write one more example. I'll create a class called as runner class. Okay, inside runner class I will have one method. This all everyone understood, I believe. Okay, so I hope you all got the clarity about what is it doing here. Okay, see, I can just write it as star over here wherein I can remove one line. Okay, so when I execute, just look at the program here and you observe array list object got created, 10, 20 we added. So objects inside array list is 10, 20, size is 2. Then linked list we created, add all, everything is done here. So now here I will make use of a method called as ll dot remove all of. Okay, I will write it as AL here. So now when I just try to print this entire process over here, look at this data, what will happen here. So when I execute the program here, see here, objects inside a linked list was 10, 20, 30, size is 3. Now when I tell remove all of AL, so remove all is used to remove one collection from another collection. So array list was storing 10 and 20. 10 and 20 is removed and only 30 is available. So this is the job of remove all here. What is the job of remove all? Remove all method, okay, is used to remove all the objects of one collection from another collection here. Okay, this is all the implementation of remove all here. Clear? So we saw totally how many methods over here. Okay, so we just saw these many methods here, right? Okay, what are the implementation of all these methods here? Tell me. Add method is used to add a single object, but add all is used to add one collection into another collection. Remove is used to remove an object based on the index position, but whereas remove all is used to remove one collection from another collection. Contains is used to check if one object is present or not, but contains all will remove one collection from another collection. Here it is going to remove, okay, one collection from another collection. And we know what is the job of is, empty, clear, and size. And iterator method, I will do it at the last, not today. Iterator method, okay, I will try to do what is iterator in the last part. Okay, and then we also saw what is the job of get method. Get method is used to get the data based on index position, okay, and index of and last index of. We have seen, okay, index of will check the index position of the object, last meaning the last index position of the object. And we have two more methods, set and add method, which we will see it now here. Okay, so now I will create the last example. I will create an object, or I'll create solution class, and I will have my main method. Main method is wherein the execution will begin from. Okay, so now over here, what will I do? I will just create an object of array list over here. Array list L equals to new array list of. I just create an object of array list. Now I'll tell L dot add of 10. Okay, concentrate now. This is slightly tricky and one of the most important interview questions here. I'm adding three objects here, 10, 20, 30 here. So now when I try to print L over here, okay, I get the output. L dot add of 1 comma, I'll write it as 50 here. Okay, and then I'll try to print the data here. So look what is happening over here initially. Okay, initially it was array list object got created and I'm added 10, 20, 30. Now when I tell L dot add of 1 comma 50, it means I am inserting 50 in index position 1. So 50 gets inserted into index position 1 and the already existing object gets shifted to the next position. So 50 got inserted in the first index position and these objects got shifted to the next position here. Got it? So the job of add method is used to add an object based on the index position. Clear? So add method, if I just tell only object here, add method is overloaded method. If I just pass only one parameter, it keeps on adding at the end of the list. But if I want to insert in between, I can make use of index position 1 comma 50. I can pass a couple of parameters. So it means index position and the object. Similarly, I have something called a set method. Same thing. When I execute the set method, look at the output, what is happening. 10, 20, 30 was the first object. Now when I tell L dot set of 1 comma 50, 50 is getting stored into the index position 1 only. But the already existing object doesn't get shifted, but it gets overridden. So that is the specification of add method and set method here. Add method will add an object, but the already existing objects get shifted to the next position. Okay, but whereas set method is also adding an object, but the already existing object gets overridden. So now I just want you all to tell me the output of this program. Okay, since you know the working of it, you have to tell me the output here. L dot set of 2 comma I'll read that 70. Can you tell me the output here? What will be the output for the first time here? Okay, when I just try to print this, what will be the output here? Can you tell me, guys? What will be the output? Think and tell me. Okay, what will be the output? Think and tell me here. Array list object got created and I have inserted 10, 20, 30. So what should be present when I try to print over here? So here it will be 10, comma, 20, comma, 30. Very good. Because I have inserted only three objects, so the output will be 10, 20, 30. So now my L is nothing but 10, 20, 30 here. Clear? Now, when I tell L dot add of 1, comma 50, it means 10 will be there here, but 50 will get stored into index position 1 and the already existing objects get shifted to the next position. It gets shifted to what? Next position over here. So it will be 10. 50 will get stored into index position 1. So therefore 50 gets stored into index position 1 and then 20 and 30 get shifted to the next position. I will get this output here. Now here, L dot set of 2 comma 70 means what is happening over here? Okay, can you tell me the output? See, 10 will be as it is, 50 will be as it is, but in index position 2, I will store 70. 0, 1 to 70 I will store, and the already existing object doesn't get shifted, it gets overridden. So the object will be 30 here. So now when I execute it, I will get this respective content. A few of them gave me wrong answers because I'm not sure if you have understood it properly or not here. So let me just show it to you in this particular example over here. Guys, it's very, very simple. Okay, see here. Array list object got created upon. See here. Why is it so complicated here? It's not at all. It's all about how we understand. L dot add of 10, 20, 30. So what is my array list now? My array list is nothing but, okay, three objects. What is it? 10, 20, 30. Correct? So now my array list is 10, 20, 30. Now when I tell L dot add of, okay, 1 comma 50, what does it mean? Add method. So first what happens here? 10 gets stored. See, this is 0, 1, 2. 10 will get stored as it is. Now 20 is in first index position, but now 50 is getting stored into index position 1. 50 gets stored over here. 20 gets shifted, 30 gets shifted. So 20 and 30. So now the index position is 0, 1, 2, 3 here. Did I get the output? 10, 20, 30, 10, 50, 20, 30. See? 10, 20, 30, 10, 50, 20, 30. Did I get the output? Same output? Yes. But now later when I tell L dot set of 2 comma 70, so it simply means 10 will be stored as it is, 50 will be stored get as it is, but in index position 2 I am storing 70. So 70 will get stored here, but 20 will not get shifted at all, it gets overridden. So it is 10, 50, 70, 30. See, 10, 50, 70, 30. Got it? So initially, okay, earlier it was 10, 20, 30. When I tell add of 1 comma 50, 50 will get stored into index position 1. 50 will get stored into index position 1. And the already existing object gets shifted because it's add method. It gets shifted to the next position. But whereas set method is going to add. 70 I'm adding in index position 2. But the already existing object gets overridden. It does not get shifted at all. So that's the reason I get the output here. Clear? So anyone having any confusions now here? Okay, with whatever we did here, any questions here? Quickly tell me. Do you want me to repeat something over here? Any questions? Good to go here? Yeah, perfect, perfect. So what is the job of add method? Add method in this particular scenario, add method is used to, wait, used to add an object based on the index position. Correct. This is the job here. Okay, add method is used to add an object based on the index position. But what will happen to the already existing object? Already existing object gets shifted to the next position. Okay, so this is all about it. Okay, and then we also have set method. So what is the object of set method here? Okay, so here the job of set method is used to add an object based on the index position only, but the already existing object gets overridden. Okay, it's not that it gets overridden here. This is what we are supposed to understand. So already existing object gets overridden. Okay, this is what we are supposed to understand. Okay, and all the methods, okay, whichever I'm doing over here is applicable for linked list as well, vector as well as stack also. See, so if I just hover on this particular diagram here, see, predefined methods present in the list interface. If it is present in the list interface, that are all implemented in array list, linked list, vector, and stack. So all those methods over here, I can use it on array list also. I can use it on linked list also, vector also, stack also. Okay. But this is all, these are all the methods which I can use it on the implementation classes of list only. I cannot use them on set. I cannot use them on queue. Why? Because these are the methods present in list. So it can be utilized by only the implementation classes of list interface. But now the methods under the collection, the methods under the collection are inherited into list queue set. From list queue set, it is inherited into set queue list implementation classes. So wherein these all methods can be accessed by all the implementation classes. Okay, such as hash set, linked hash set, priority queue, everywhere we can utilize it because it's from collection to list queue set, from list queue set to its respective implementation classes. But the methods from the list interface is implemented only in the implementation classes of list interface only. Okay, so I hope you all got the clarity now. Okay, clear. Okay, and for loop here, when I made use of for loop over, see, add all, remove all, I can use it with respect to only array list, only linked list, or a combination of all. So I'm just giving you the working, but you can use it wherever you want it. Again, for loop, I did it for array list over here. You can do it for linked list also because they're all index based, right? So if I make use of for loop and if I'm traversing here, I can make use of linked list as well. It doesn't matter. It's just that how good we understand and try to work around with the programs here. Okay, so this is all about the entire process here. Okay, so I hope we just got the basic idea about a few things over here. Okay, and we have one more most important and the trickiest interview question here. Okay, so they'll tell you, okay, what is the difference between, okay, collection and collections? Okay, minute difference here, guys. Collections. Collections is a predefined interface, but collections is a predefined class. This is present in java.util package, and this is also present in java.util package. It was introduced from JDK 1.2, and even this was introduced from JDK 1.2 only. Okay, so what are we supposed to concentrate on? Collection is a predefined interface in java.util package introduced from JDK 1.2. But collections is a predefined class present in java.util package introduced from JDK 1.2. Okay, so this is what we are supposed to understand. Collection is an interface, collections is a class. Okay, so that way you can make use of a lot of things here. Okay, see here, I'll give you one example over here. Okay, I will have a class here. Okay, and I will have my main method over here. See here, oh, not main method, I will have an object of array list. Okay, array list L equals to new array list of, I'll create an object of array list over here. Okay, perfect. I created an object of array list. I tell L dot add of 30, L dot add of 40, L dot add of 10, and L dot add of, I'll write it as 10 over here. Okay, 20 over here. Okay, so now here when I try to print L over here, since array list maintains insertion order, I'll get the job of it. See, I'll get the output as 30, 40, 10 here. But I want to sort it. Therefore, I have a predefined class. What is the predefined class name? Collections. Why is it giving an error? Because I have collections is a predefined class present in java.util package. So inside that we have a method called a sort method. Collections is a predefined class present in java.util package. So I have to import the collections class. Okay. And inside collections class, we have a static method called a sort method. See, when it is sort of, it is accepting a list over here. Look at the first part, it is accepting a list here. And I have to pass the list over here. And when I try to print this over here, if I execute it, look what is the output you get. I get the output as 10, 20, 30, 40 here. Got it? So collections is a predefined class, whereas collection is a predefined interface. So in collections class, we have a static method called a sort method. And the job of sort method is used to sort the content based on the index position. Okay, based on the index position here, it is going to sort the data. I mean, oh, not ascending order, natural ascending order, it is going to sort the data here. Okay, not on index position, I'm so sorry. Sorting, you know what is sorting, right? Natural sorting order is ascending order. So it is going to sort the collection here, the list specifically. If you want, you can traverse it with the help of for loop also. You can write for loop for int I equals to 0, I lesser than L dot size, okay, and then I plus plus here. And you can just write it as L dot get of I over here. The same for loop also you can write it down over here. Okay, this was before sorting. I'll write it as before sorting I got this content, and after sorting, so I can just write it as sysout after sorting this respective content here. That way I can try to do it over here. See, main class. So if I try to do this, look at the output what I get here. Simple. See, I get this respective content here before sorting and after sorting. Wait, I'll just pull it down. You get the output. See, before sorting it's 30, 40, 10, 20. After sorting it's 10, 20, 30, 40. So these are the few things which we are supposed to understand when we talk about collections, guys. Okay. So this is all about the major important point with respect to collections here. Okay. So anyone having any questions, guys, as of now here? Anyone having any questions here? No? Clear. Perfect, 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 perfect. Okay. So now here I'll just do one more small topic here, guys. Don't kill me. Okay, just 5 more minutes, not more. Okay. So generally in an interview, they'll definitely ask, can you tell me the difference between array list and linked list here? They'll definitely ask this question, guys. Okay. What is the difference between array list and linked list here? Okay. So we are just supposed to remember all of those. Okay. Uh, that you're already presenting. Okay. So there is one more part over here. Okay. Why they could not just add this type of sort method already present in array list or linked list class? Why create confusion by creating in collections class? Okay, great. Okay. The only reason being here, okay, see here in real time over here, we had to compare objects and sort them. Now it was very easy to sort what numbers over here. Okay, it is very easy to sort numbers here. What if you have to sort employee objects here? What if you have to sort student objects here based on one particular criteria here? For example, if you want to sort student objects based on their marks and store them in one particular order, then it becomes a problem, right? So that's the reason here they have had a generic class wherein it can be used by everyone. Okay, because not all the things I can compare it, right? If it is in collection interface, okay, it can be implemented by everyone, but hasset has certain specifications as well. Okay, because wherein duplicates are not allowed, it is not index based, insertion order is not maintained. So we have a lot of problems under set interface also, because it internally makes use of hashing here. Okay, so that's the reason. So later you will understand why do we make use of comparable, why they have given it in generic class. You will understand that later. Okay. So yeah, great. So now let us try to talk about this entire data here. Now array list here, guys. Okay. So let me tell you the specifications as well as the easy way. So what is array list here? It's a predefined class in which package java.util package. Correct. The same with respect to linked list also. Correct. No. The same with respect to linked list as well. So let me just try to Write it down. Come, not differences here. Quickly, I'll try to do it over here. Okay, because we already know it, right? So what is it? This is also predefined class in Java dot util package. Okay, this is the first difference. Second, when was it started from? Sir, it was started from JDK 1.2. Correct. It was started from JDK 1.2. The same with respect to, okay, the same with respect to them also. Okay. So with respect to linked list also, it was started from JDK 1.2. Third difference. Okay, third difference over here. Uh, what is the initial capacity over here? What is the initial capacity of array list, guys? Any idea? Quick idea, quick idea. What is the initial capacity of array list here? Quickly tell me. Very good. The initial capacity in array list is 10 over here. What about linked list, guys? What is the initial capacity? What is the initial capacity in linked list here? Actually, we don't have no initial capacity at all. Okay, linked list does not have any initial capacity. Very good. So then, fourth one. What is the incremental capacity? What is the incremental capacity of array list over here? Incremental capacity is, okay, how do you answer this, guys? It's nothing but current capacity into 3 by 2. Okay, current capacity into 3 by 2 plus 1 here. Okay, so that is what we will try to write it down over here. CC means it's current capacity. Okay, current capacity into 3 by 2 plus 1 over here. But what about incremental capacity in linked list here? What about the incremental capacity in linked list here? We don't have incremental capacity only, sir. No incremental capacity with respect to linked list here. Very good. Okay. And the fifth difference here is, what is the underlined data structure here? Underlined data structure in um, array list here. Structure. Okay, array list is nothing but resizable array. You know, you have to be very specific in answering it. Okay, it's resizable array, or we also call it as growable array here. Okay, resizable array or growable array. Whereas in linked list over here, it's very easy. Okay, whereas in linked list, it's nothing but doubly linked list over here. So let me just write it down. It's doubly linked list. Very good. Okay, it's doubly linked list here. That is the certain differences. Okay. So now the sixth part here is, okay, array list is always sequential memory allocation. Okay. What do you mean by that? Okay, I'll tell you here. And this is nothing but non-sequential memory allocation. Whenever you talk about array list, it is sequential memory allocation. Linked list, it's non-sequential memory allocation. Why? I will tell you over here. Okay, see here. Let me just tell you over here. Yeah, this is more than sufficient for me. Yeah, just a moment. See, in this specific data, right? Whenever I make use of array list over here, it is, since it is storing in the form of an array here, it is always sequential. 10, after that 20, after that 30, after that 40, after that 50. It is sequential memory allocation. But whereas linked list, it's non-sequential. 10 will be stored over here, and it is connected to 20, and it is connected to 30, and it is connected to 40, and it is connected to 50 here. Linked list, it's also storing. Since they're connected with addresses over here, this is non-sequential memory allocation. So linked list is non-sequential memory allocation. Array list is sequential, one after one after one after you'll get stored. It's like roll number. Okay, if students are there, roll number 1 will be storing here. Roll number 2 will be stored here. Roll number 3 will be stored here. Roll number 4 will be stored here. Sequential memory allocation. Okay, so this is the reason array list sequential, linked list non-sequential. Okay, and then last one is array list has 3 constructors. Okay, and I have not spoken about constructors with respect to that here, but array list has 3 constructors, whereas linked list has 2 constructors. Okay, that I will talk about it when I do vector. Okay, it has only 2 constructors in linked list. So these are the certain differences here between array list and linked list over here. Okay, got the clarity over here. Okay, so these are the major differences between array list and linked list over here. But there will be one question, sir. Okay, sir. When do I choose array list, sir? When do I choose linked list, sir? Very, very, very simple over here. Okay, see here. I will tell you. When do you choose array list? When do you choose linked list over here? Let me just explain it to you in a beautiful manner here. Okay. So now, since array list, okay, see here. If I just tell array list I've stored and I'm storing 10, 20, 30. Now my requirement is I want to insert, okay, 50 in index position 1 here. Okay, index position 1. What is the requirement? Your array list was storing 10, 20, 30. Now you have to insert 50 in index position 1. So now internally what will happen? So in simple terms here, 10 will get stored, 50 will get stored into index position 1, and 20 gets stored over here, and 30 will get stored over here. Got the clarity what is happening over here? So whenever you try to insert an object in between here, shifting is involved here, right? The already existing object gets shifted into the next position. Now the next requirement is I want to remove object from index position 1 here. I want to remove an object from index position 1. So now internally what will happen here? So again 10 is stored over here. Since I'm removing 50, index position 1 is 50, I remove 50, this gets shifted back to the previous position. 20 will get stored, 30 will get stored, meaning it gets shifted over here. Okay, it gets shifted. So in simple terms, what did you understand? Sir, when I make use of array list, and if there is insertion or deletion in between, I repeat, if there is data manipulation, lot of insertion, deletion here, shifting is involved. Wherein shifting reduces efficiency. Efficiency goes for a walk. Okay, efficiency is decreased. But whereas in linked list, it's much efficient here. See, it is storing 10 nodes, no? 10, 20, 30. So what is the requirement? Store 15 index position 1. This is, imagine this is 0, 1, 2 index position. Okay. This is 50. I have to store 15 index position 1. They are all connected now. Okay. They are all connected. Now in simple terms over here, I have to store 15 index position 1. So what I'll do, I will create a new object called as 15, and I'll just make sure they break their connection over here. They break their connection over here. Okay. After breaking the connection over here, I'm just supposed to connect this. Now 10 will start pointing to 50 and 50 will start pointing to 20 here. This will become 2, this will become 2, this will become 3 here. So whenever I'm adding an object into linked list, no shifting is involved. Just the addresses they are storing in their respective position only. But only the addresses are changed here. If I want to remove 50 here, simple. 10 will be stored over here. This 50 in memory location is gone. Now it starts pointing to 20 and starts pointing to 30 here. So what did you understand here? If there is a lot of insertion and deletion in between, you're trying to insert, delete, insert, delete, insert, delete, a lot of times here, you will always choose linked list. Why? Because when I use array list, shifting is involved and the efficiency is comparatively less here. Okay, efficiency is comparatively less. So if there is a lot of insertion, deletion, manipulations involved, I will make use of linked list. Why? No shifting at all over here. So wherein the efficiency is comparatively high here. Got it? So this is wherein we generally make use of linked list over array list here. Clear? So now one more data. Sir, my requirement is to store and fetch the data, retrieve the data. I want to store 1000 objects and fetch those 1000 objects. So which is easy, sir? Always array list is easy. Why? Array list is sequential memory allocation. For example, imagine I'm working on a student project. See, roll number 1 is stored over here, roll number 2, roll number 3, roll number 4, roll number 5. Okay, 5 students are stored in sequence. So if I want to fetch here, roll number 1 immediately comes, roll number 2, roll number 3, roll number 4, roll number 5. Sequentially, since array list, if I want to just store and retrieve the data, store and fetch the data without any manipulations, I will always use array list over here. Why? Because they're in a sequential memory allocation. Fetching the data will be very, very easy here because in sequential. But now when I make use of linked list, roll number 1, roll number 2, roll number 3, roll number 4, and roll number 5.
Since it's non-sequential, if I tell roll number 1, he comes here. Roll number 2, non-sequential. It takes time. See, imagine if there is a classroom over here, student 1, student 2, student 3, student 4, student 5. They're in sequential. If I tell student 1, he comes immediately. Student 2, immediately. Student 3, student 4, student 5. What if they're stored in random order? Roll number 1 here, roll number 2 here, roll number 3 here, roll number 4 here, roll number 5. Roll number 1, he has to come. Roll number 2, he has to come. Roll number 3, he has to come. Roll number 4. It becomes non-sequential because there are other objects over here, right? So that's the reason. So if I just want to store the data and retrieve the data, okay, without any manipulations here, I will always choose array list. Why? Because it's sequential memory allocation. Sequential memory allocation meaning retrieving becomes very easy because they're in one particular order, sorted type of order. Okay. But if it's non-sequential, it becomes difficult. So this is the major difference between array list and linked list, and when do we choose what here. Clear? So this is all about the most important difference between array list and linked list here. Clear? So anyone having any questions with respect to today's session, guys? We did a lot of topics here. Okay. I thought I'll not upload the videos here. Okay. Because there was some issues over here, but let me upload it because I want you all to refer it for at least a few more days. Okay. I'll be done with this entire process in a few days. Okay. So I'll upload the videos also, go through it because I want quality, guys. Okay. So I'm putting an extra effort here. I'm taking a lot of risk as well. Okay. At the same thing, you have to realize the importance of it and try to work around with it, right? So you have the accessibility now. Okay. Utilize it in a very good way. Okay. So this is all about it, guys. Okay. So anyone having any questions in today's session? Oh, any questions? Okay, perfect, guys. Okay, so work around with whatever questions, I mean, whatever we did in today's session, so that tomorrow we'll start with a new topic. Okay, collections only, a new topic under collections. Okay, so great, guys. Okay, so we shall wind up a session for today and catch up tomorrow. Okay, so thank you all. Take care. Bye bye.